Using bond enthalpy, that means I'm going to have to draw out my Lewis structures. If they gave me a reaction, I'd start with my Lewis structures, but because it said, I believe it actually said combustion of C2H6, I need that reaction first. C2H6 plus oxygen makes CO2 and H2O. 2 carbons, so I need a 2. 6 hydrogens, so I need a 3. That's 4 plus another 3, so 7 oxygens. 7 halves O2 will get me 7 oxygens on the left. For drawing out my Lewis structures, a bunch of C's and H's. The C's go in a line, the H's go around it. I know that each carbon needs 4 bonds and each hydrogen only needs 2, so I'm going to shortcut it. With single bonds, all my hydrogens are happy. Each carbon currently has 3 bonds, so I just need a single bond there to make the carbons happy. For the O2s, I can't draw it 7 halves times, so I'm going to draw O2 like so. You've hopefully drawn it enough times that you just know it's a double bond, but if you needed to really draw out its Lewis structure, you could. And there is a review video about how to draw Lewis structures posted online. CO2, carbons and my oxygens. Carbon needs 4 bonds, so it must be double bonded to the oxygen. That's enough to know all my bonds. I don't have to keep going with it. Personally, I like to draw it a second time because of the coefficient. You only have to draw it once for full credit as long as you can do the math correctly. For water, hydrogens can each only have 1 bond, so I know that these max out at single bonds, and that's enough. 3 waters. Now, looking at bonds that I'm breaking, I'm always going to break the bonds of the reactants. I'm always going to make the bonds of the products. That matters because breaking will end up positive. I have to put energy in to break those bonds. Making will end up negative. I have to release energy to make those bonds. Of the things I'm breaking, there's a CH bond, 2, 3, 4, 5, 6. 6 C to H bonds. I haven't yet accounted for this C to C bond, only one of them. And I have 7 halves O double bonded to O. The side I'm making, that's a C double bond to O, another one, another one, another one. So I have 4 C double bonds to O. In terms of O single bonded to H, I have 1, 2, 3, 4, 5, 6. Now I get the values from the back bottom of this chart. 6 times 413 plus 348 plus 7 halves 495. Whatever I get here, I'm going to make positive. 4 times 799 plus 6 times 463. Whatever I get here, I'm going to make negative. 6 times 413 plus 348 plus 7 halves times 495. My breaking side. For my making side, I get 5974, but it's negative. So my calculator, 4,558.5 plus negative 5974. I end up with negative 1415.2. I hope that came up on the screen. Yes, it did. And you'll just use the units off of the chart, kilojoules per mole. And we're done.